and you're supposed to get that. Okay? Now, let's do a bit of some interpretation. Right? I'm going to assume that you sketched your graph and you got something like that. Okay? Now, when you're sketching a graph, please try to choose a scale which will make you draw a large graph. Don't squeeze your graph on a small area. Okay? Don't squeeze your graph on a small area. You need to choose a scale which will make you have a large graph which is easy to see. Okay? So, based on the equation g of x, okay, remember the equation of the function is g of x. The equation of the function is g of x equal to x cubed minus 8x squared plus 5x plus 14. Okay? So the y-intercept is going to be here at y equal to what? 14. Then you use the vector theorem. In this case, you could use your calculator to determine the coordinates of the x-intercepts, or to determine the x-intercepts. Those are your x-intercepts. Then you need to find your first derivative. So your first derivative is 3x squared minus 16x plus 15. We use the first derivative to determine the coordinates at the turning points or at the stationary points. Right? We find the x values first by equating g prime of x to 0. So you equate the first derivative to 0, then you solve the quadratic equation. You get two x values. So those two x values, one is here, the other one is there. And then you use those two x values to determine the corresponding y values. Fortunately, I've got the coordinates. Okay? So if you look here, don't worry that I deleted the b's on the graph. Right? So I've got this value here. It's going to be minus 36. So that's the point. Okay? Then at this point here, y is 15, which is going to be, okay, y is 15 at the other point. It's not 15, but it's 14 comma something. So it's that point. Okay? Okay. All right. Let's remove that. Yeah, I put minus 15 plus 15 instead of 5. Okay. Let me fix that. Okay. So that should be plus 5. Okay, this is plus 5. So then you put g prime of that should get C. Alright, so our turning points are there. Now it's also important for you to know that at the turning points here, the derivative is 0. At the turning point, g prime of x is 0. At the turning point here, g prime of x is 0. Okay? And this point here is also called a local maximum. That's another terminology. This is called a local maximum. It's called a local if you are referring to a point which is close to that turning point. Okay? Remember, local means within the area, isn't it? Huh? And this is also called a local minimum. These are calculus terms. Okay? But I prefer to use turning point or stationary points. Okay? Now, our point of inflection is this one. That's the point of inflection. Okay, let me use green there. So this is the point of inflection. It is a point where the graph changes its concavity. Right? Fortunately, I've got that point. Okay, where is it now? Okay, it's here. So this is the point, and those are exact coordinates. 2,66, which is the same as 2 2/3, which is 8 over what? 3. So here, x is 8 over 3, and y is what? Okay, let's put here minus 10 comma minus 10,59. Okay, that's the point of inflection. So if I want to determine the values of x for which the graph is concave down, okay, so it's concave. Okay, use color there. Use that one. So the graph is concave down when x here, because this point here, it is to the right of the maximum turning point, so x is going to be less than 8/3. Can you pay attention, please? The graph is concave down to the left of the point of inflection. Yes?
So you could also do it by saying second derivative basically and solving that way.
Were you here yesterday? I discussed it. Yes.
You can just use, you can
Yes,
do it that way.
you can use the second. Your second derivative will be less than. It will be less than 0. We discussed that. Unfortunately, it's here.
That's fine.
Okay. All right. Then concave up. It's concave up to the right. Pay attention. To the right of the point of inflection. So x is greater than 8/3. Okay? If you don't want to, can I have your attention please, to use the point of inflection to determine the concavity, you have to find the second derivative. When it's concave down, the second derivative will be less than 0. Remember, when it's concave down, the graph is unhappy. Therefore, the second derivative is negative. So, it's concave down. Okay, the way that I remember this, okay, I think I told you I'm going to repeat it. Right? Down, concave down means the graph is unhappy. If it's unhappy, it's negative. What's negative? Second derivative. Right? Then, when it's concave up, the graph is happy. So, our second derivative will be what? Positive. So, get your second derivative, plug it in there, simplify. Solve for what? For x. If it's concave down. Concave up, get your second derivative. Can you pay attention? Get your second derivative, plug it in there, in the inequality, solve the what? Inequality. I call this free marks, because this is so easy. Now, another way of finding the point of inflection besides the second derivative is to use, please pay attention because I didn't talk about this yesterday. Now, I'm using this graph to explain these concepts. Okay? We can also use the coordinates of the stationary points, the x values. So the x value at the point of inflection is always equal to the x value, the first x value at the turning point plus the second x value divided by 2. That's another way of finding the x value at the point of inflection. Can you pay attention? Pay attention. So if you don't want to find the x value at the point of inflection using the second derivative, if you get your x values at the stationary points, you just add those values, divide them by 2. You will get your x value at the turning point. Sorry, at the point of inflection. So let's test that. Let's test that.
So is it always going to have like this is as wide as this, or can you have something that's thin and then a wide?
Okay, for the calculus,
Because like they look
in
as
your case,
wide.
we deal with cases where the distance from here is, well, if you measure distance from this point to a similar point which is horizontal. The distance from there to whatever point is there is the same as from here to there.
But that's not always.
Yes, but for your curriculum, that's the main focus mainly. Okay. Right. So, what was the first x value? It's your choice. So the first x value here, we have got it, right? Okay, I can use 14,81. Not 40, sorry, I can use, okay, this is a third, okay, 0.33. So I can say a third plus this 5 here, plus 5. Then you divide the answer by 2. So this will give you 5 and a third, which is the same as 16 over what? 3. If you divide that by 2, you come to 8 over what? 3. What is 5 and a third divided by 2? Huh? It's what? 8 over 3. So you get what? 8 over 3, which is the same as that. Okay? So you have two ways of finding the x value at the point of inflection. You can just add the x values at the stationary points. You add them, get their average. That would be the x value at the point of inflection. Okay? Are you following that? Nice. What else? Then we also need to know for what value is the function increasing or decreasing. Right? So when it comes to increasing or decreasing functions, if you sketch the graph, you don't need to use the derivative. Okay? If you sketch the graph, you don't need the what? The derivative. So it is increasing where you look at your maximum turning point to the left of the maximum turning point and to the right of the minimum turning point. What is the value of x at the maximum turning point? Okay, I know that one is a third. So my answer is going to be x is less than a third. Or the x value there, I need to know that one is 5. So x is greater than what? 5. I hope I'm not talking to myself here. I hope I'm not talking to myself. Now, when you have the graph, it's very easy to determine what values of x the graph is what? Is an increasing function. When you don't have the graph, you have to use your knowledge of quadratic inequalities. Remember, if the function is increasing, the first derivative will be positive, isn't it? Huh? Some of you is like you are sleeping or something. So what? Then it's decreasing. Sorry. You're supposed to answer all this.
On the graph paper?
Yes.
I just did it in my book.
So it's decreasing. Okay? It's decreasing when the y values are what? Are decreasing. So the y values are decreasing from here all the way up to there. So which means our two values of x, that is the lower limit and the upper limit, are going to be a third is less than x is less than 5. Okay? If the graph was not drawn, then this second derivative, can you pay attention? Because I'm also doing interpretation here. It's part of interpreting what I'm doing now. Right? You use this second the first derivative, it will be, if it's increasing, it will be greater than what? 0. If it's decreasing, it will be less than 0. Then you solve the quadratic inequality. Remember, you did quadratic inequalities last year. Do you remember that? Yes. Don't tell me that you can't remember, because next week on Friday you need to know how to solve a quadratic inequality.
Next week Friday.
Yes. Huh?
I normally always draw a small sketch.
If there's no sketch, then you might need to use the first derivative. and apply a rule of quadratic what? Inequality. Yes? Any one of you?
Just because I didn't realize it. Basically saying if it's an increasing function, then the first derivative has to be
Positive.
positive.
And if it's a decreasing function, the first derivative must be negative.
So switch to
Yeah.
in the case of this graph, if we're given a question, what values of k would f of x equal to k have three unequal roots? What do you do?
You know why I'm smiling? Because I was when I get there. Okay. So that question that you are asking now, for your examination, you are not going to put that because remember, I think it's the other class that I taught today. Your June examination, we made the calculus a little bit easier because remember we are teaching calculus now. We are not going to finish it. We still have to carry on after the exams. That's why you have no holiday. You have no holiday until the last day. You have to continue coming to school. Okay? So that type of a question now, it's a very, very easy question. And I will show you how to do it using like a horizontal line test. Okay? It's a very easy question. Okay? It's a very easy question. And we didn't put a question like that in the exam because we didn't want to cause issues. Okay? But you are going to write, listen, you are going to write a calculus test, which will be your last standardized test for your high school. Okay? You write that, I think, based on the current school program, the last day of school. A curve can be a cubic function or a quadratic function. Okay? So, let's talk about this scenario. So you already know some of this stuff. Okay? So if I have a Cartesian plane, right, allow me to just draw a curve, but not one which is exponential or logarithmic. Let's deal with the cubic one. Okay, my line has disappeared. So let's say redo. Okay, so we are back now. One like this. Okay, so let's say you have a cubic function like that. Then we choose a point where we can draw a tangent, probably here. Okay, let me just allow me to adjust this point. I think I can enlarge it too. Yeah. So with that point, it's nice, isn't it? It looks nice. Okay. Okay, my pen, allow me to recalibrate please because it's not doing what it's supposed to do. Fortunately, I can redo, so I'll come back to it. But I just want to recalibrate. Okay, let's redo. All right, can you pay attention? Because, okay, it's back. I need you to ask that after I finish this. Okay. Alright, so if I draw a tangent to this curve, please pay attention. Right? At this point, that is called a point of contact. Right? Remember, a tangent is a straight line. It is a straight line, right? Since it's a straight line, means it obeys the equation y equals mx plus what? Plus c. When you want to calculate this gradient, it's y2 minus y1 over x2 minus what? x1. Now, if we merge our knowledge of a straight line and tangents, and then the cubic function, which is part of calculus, we can end up coming to this point where, at this point, that point of contact is called a point of contact, right? The gradient of the tangent at that point of contact will be equivalent to the first derivative of the cubic function. Remember, at the beginning, I told you that the gradient m is equivalent to f prime of x. Okay? So sometimes, if we want to find the equation of the tangent, if you are given the equation of the cubic function, you can find its first derivative. Okay? Then you probably have to equate that first derivative to 0. Okay, if you equate to 0, you get the stationary points, but you may be given a specific x value here. So you substitute that x value into the first derivative to get an actual value of the gradient. Okay? So the gradient of a tangent is equal to the first derivative of a cubic function or of any curve at the point of what? Contact. Only at the point of contact. So the x value at this point here and the y value at this point, for both of them, that is the tangent and the curve, in this case we call it f of x, they will be equivalent. Okay? So sometimes you may be asked to determine the equation of a tangent at this point. Okay, let's say this point, maybe we can call it x is minus 3. Okay? If x is minus 3 there, and we know the equation of the function, then we can be able to find the equation of the tangent. Okay? So we use this fact that m tangent is equal to f prime of x at the point of contact. Okay? So that's the fact to use. So to determine the gradient of the tangent, you need to be given a specific value of x on the cubic function or at the point of contact. Okay? Okay, just to do an example based on, can I move on? Equation of tangent, yes. Okay, so I'm going to work backwards. Alright, let me choose a point on this graph. So, okay, let me make it simple. So let's say, okay, we've got a point here. X is what? 6. X is 6 there. Right? Let's draw a tangent. It doesn't look nice. Yeah, I'm concerned about how something looks. So, can I have your attention? So we need to determine the equation of that tangent. Fortunately, the point of contact is at x equal to what? To 6. Okay, so what we have to do is, we know our first derivative already, fortunately. So g prime of x, okay, g prime of x is equal to 3x squared minus 16x plus 5. So it's 3x squared plus, okay, minus 6x plus what? 5. Okay? Alright? Now, this g prime of x is equivalent to m of the tangent. The first derivative of a curve is equivalent to the gradient of a tangent at the point of contact. Okay? So, let's find g prime of x, which is equal to m tangent. So So all we have to do is let's put what? 6. Okay? Okay, let's put this is the correct notation. Yes?
It's supposed to be minus 16.
Minus 16. Okay, I'll change that. So this is minus 16. So M tangent is equal to G prime of 6. G prime of 6. Okay, just to explain what it means. It means the gradient of f of x when x is 6. Okay? So we substitute 6 into the first derivative. And then you get here 36 by 3, you get 108. 16 by 6, so that's 90, 96 plus 5. So if I simplify this, these two give me 12 plus 5, I get 17. Okay, just check that for me. But I think it's correct. It is correct. Right? It's correct, isn't it? Right? So what this means is our gradient of our tangent at the point of contact where x is 6 is going to be 17. That's the gradient. Okay? So if you want to find the equation now of the tangent, we also need to know what is the value of y at that point of contact. Okay? We have found the gradient, but we need to know what is the value of y. So to find the value of y, we'll say f of x, we need the actual function, the original function. So it's f of x equal to that. So that's x cubed minus 8x squared plus 5x plus 14 plus 5x plus 14. So this is the original function. So the question is, what is the value of y where x is 6? So we'll put what? 6 here. So this will be 6 cubed minus 8 times 6 squared plus 5 times 6 plus 14. So this will give me, okay, 2 what? 6 cubed, 36 by 6. It's 216. This is 2 what? 50.
I don't understand. I can't do math like that.
Okay. You know what? Recently I found a method which is very interesting of doing multiplication. Okay, you subtract 1 here, you get 2. Right? Then 6 times 6 gives what? 36. Okay, I think I need to go back to that method. I need to go back to, but it was very interesting. Okay, you won't have to stress anymore. Right, so this is 6. Then you have got 3 there. So I was right, it was 260. I was right here, so 216 minus 36 by 48. So 36 by 8. So that's 8. Made of 4, there was 24. Right, so that's 288. Minus 70, 72. Right? Please can just help me to check this. If I get 22,
Minus 1.
minus 1, minus 28. That's what you got. Okay. Sorry. There's a minus here, so that's alright. So the value of y at that point is going to be minus what? 28. Fortunately, we could have found it on the graph itself. Okay? If I go back to the original graph on GeoGebra, I could have found it, but we don't have time. Okay, I've got 10 minutes. I'm almost done though. Alright. So now that we know the gradient, we know the y value at the point of contact, we know the x value at the point of contact, then we are back in grade 9. Okay? Remember, a tangent is a straight line. So y is equal to mx plus c. What is y? Minus 28. What is the gradient? 17. What is x? 6. So this will give you minus 28, 17, that will be 102. And then if I take it the other way, I'll get minus 130. So this, therefore, the equation of the tangent is going to be equal to y equal to 17x minus 130. That will be the equation of the tangent. Okay. So it's not that complicated. Now a question like this one here, to have minimum 4 marks. Because there's quite a lot that you have to do. And this is the easiest type though. I've done the easiest type. I'll do the higher order later on, which requires you to apply your knowledge of simultaneous equations. And I'll do that after the examinations. So up to there, you should be ready for your June exam next week. Yes.